Hello fellas, I would like to show you how to operate the Echo-Pac program for the analysis of strain in echocardiography. So for starters, let's open the Echo-Pac program, clicking on the icon. Now type the password and log on. To import exams from a memstick or a DVD or a CD or external hard drive, select Import on the menu. When importing from, in this case, choose a USB DICOM USB HD memstick. Press OK. Type the correct date. The exams will appear. Select the exams you would like to copy and import, in this case all, by selecting all, and hit copy. When finished, select done and proceed to select the exam for analysis by double clicking on it. Proceed by selecting an apical 4-chamber view. Just remember, when choosing the proper apical 4-chamber, that you want to see the endocardial border as clearly as possible in order to have no troubles with the tracking analysis. In this specific case, I would probably go with number 2 here. So hit Q analysis and 2D strain to proceed, and select the proper view, in this case 4 chambers. Now the software requires of me to track the endocardial border with the mouse, and there are two methods to do this. The first and simplest one is actually to rely on the software by tracking manually just a triangle, letting the computer do all the tracking. You will just have to correct it, like I'm doing in this case, and the other one, going back by new region of interest, I said going back, is by selecting the endocardial border manually, like I'm doing right now with the mouse. You can then fix and make minor corrections to the tracking. But when you're satisfied, hit process. If the software is satisfied with your tracking, you will have all the segments with a green check. In some specific cases, the software will be unable to track it or will deem the tracking unreliable and will mark those segments with an X. So at your discretion, either check again in green those segments, go back by recalculating, or just proceed with the results like I'm doing right now, by hitting approve. In this table, the longitudinal strain results are represented. Each curve in a different color represents a specific segment, and what the graph shows is the change in longitudinal strain over time in milliseconds. AVC in this case stands for aortic valve closure, and it marks the end of systole. Just a side note, GHAS here stands for global longitudinal strain. Now we want to proceed to see the actual numbers, and now we'll see the tables. By clicking on results, we can now access all the numbers we can extrapolate from this specific dataset and echocardial exam. If you want to see the longitudinal strain, just click on SL and you'll see all the numbers listed here. For reference, we're gonna need most likely just 2 of these waves. We will not consider the peak P, we will just consider peak G and peak S. Peak G stands for post-systolic longitudinal strain, and it is usually the systolic strain which actually happens after the aortic valve closure. The peak S stands for systolic longitudinal strain, and it is usually marks the systolic strain which happens either at the aortic valve closure or before it. Proceeding further, on SRL, we'll see the longitudinal strain rate, and here we might need all these points in the curves, remembering that PKS stands for systolic longitudinal strain rate, E stands for early diastolic longitudinal strain rate, and A stands for atrial or late longitudinal strain rate. So when satisfied with the results, you can copy the numbers or take a snapshot, exporting the image, and then you can go on and proceed with your analysis by hitting exit and storing the loop. Now I'm going to proceed to analyze the apical two-chamber view from the same patient. So 2D strain in 2 chambers. I'm going to try the simple method. Let's see if the software actually helps me out, which it didn't. Then I have to fix it for the most part. Remember that when doing this tracking, I'm following with my eyes what I believe is the endocardial border. When I'm finished with the corrections, I can hit process and see what the software thinks of it. So luckily enough, the software likes it, so I can proceed with the proof. And same thing as before, I can proceed with the results. So longitudinal strain rate. Exit and store the loop. As another example, I'm going to show you what happens when you actually miss completely the point when trying to track the software when tracking the endocardial border with software. So let's say I will not do any corrections and let the software do whatever he wants. Okay, still here I liked it, but let's presume I don't want to be precise at all, just to show you what might happen. Hopefully the software will say it doesn't like it. Okay, so in this specific case, the apical anterior wall was not accepted. But let's see, let's approve it and see what happens. So on the graph here, you can see that this specific segment is not included in the analysis. So you see a hole in this graph representing longitudinal strain. And if you want to work on it and fix it, you can just recalculate, and you can either fix the endocardial border with some patience I'm doing here right now. and proceed with process. As I showed you before, by approving, you can proceed with your analysis. Thank you for watching.